At first glance, it's just mist, swirling gently at the foot of a roaring waterfall. But what if I told you that this delicate cloud is actually the result of powerful forces, forces that obey the laws of energy, motion, and heat? Welcome to Variantica, where we explore the hidden science behind everyday wonders. Today, we're diving into one of nature's most elegant processes, the formation of mist at Nigra Waterfall, through the lens of thermodynamics. How does water become airborne mist? What invisible thresholds does vapor cross to become visible? And what keeps it hanging there, as if suspended by nature itself? Let's break it down, one principle at a time. Nigra Waterfall is not only a visual marvel, it's a living display of thermodynamics. As water crashes down, a cloud of mist rises. But where does that mist come from? How does falling water transform into mist in the first place? As water descends, gravitational potential energy converts into kinetic energy. When it hits the rocks below at high velocity, the force shatters the stream into countless tiny droplets. This is explained by Bernoulli's principle. But how do those droplets stay suspended in the air and not fall right back down? The collision stirs up air currents that carry the droplets upward. As the moist air rises, it expands and cools, a process known as adiabatic cooling, governed by the adiabatic lapse rate. What happens when this rising air cools enough? Does it change the air itself? Yes, when the air temperature drops to the dew point, water vapor condenses into liquid droplets, forming visible mist. This phase change releases latent heat, as described by the first law of thermodynamics. But what determines the exact moment that vapor turns into mist? That moment is predicted by the Clausius, Clapeyron Equation, which shows how vapor condenses when the air reaches a specific saturation point, where temperature and vapor pressure align perfectly. So, once mist forms, why doesn't it just vanish immediately? The mist persists because the surrounding air behaves like an ideal gas. Changes in temperature and pressure help sustain the fine balance that keeps droplets suspended, rather than falling or evaporating too quickly. What does all this tell us about the waterfall itself? It tells us that a waterfall is more than just falling water. It's a natural laboratory, where fluid mechanics, thermodynamics, and atmospheric physics all come together in perfect harmony. From energy to equilibrium, Nigra Waterfall teaches us that even a simple mist is powered by powerful physics. If this video is helpful for you, please like, share and subscribe and hit the bell icon for my latest update.